Hey everyone, today we're diving into a fascinating study that challenges our understanding of the Atlantic Ocean circulation. You might have heard that warm, salty water from the Indian Ocean plays a crucial role in this process, but this new research reveals a more complex story. So, let's explore how a cooling event 3.3 million years ago changed our thinking about this oceanic phenomenon. First, let's set the scene. The Atlantic Meridional Overturning Circulation, or AMOC, is like Earth's climate control system. It moves warm surface water from the tropics northward and brings colder, denser water back south. This circulation influences the climate across the North Atlantic and parts of Europe. For decades, scientists have linked the strength of this circulation to something called the Agulhas leakage, which is essentially the flow of warm, salty water from the Indian Ocean into the Atlantic. The traditional explanation goes like this. More salt from the Indian Ocean makes the Atlantic surface water denser, causing it to sink in the north. This sinking helps form North Atlantic deep water and keeps the AMOC going strong. But here's the twist. A study by Dr. Suning Ho and an international team of researchers found that this simple explanation doesn't always hold up. They focused on a cooling event that happened around 3.3 million years ago, known as marine isotope stage M2. This period was a natural experiment for understanding ocean circulation near South Africa and across the Atlantic. By analyzing sediment cores from the Agulhas Plateau, they found evidence of a shifting ocean front. The key to this discovery was tiny marine plankton called dinoflagellates. These plankton leave behind fossil cysts that can tell us where ocean fronts used to be. When the researchers saw a change in the dinoflagellate record, they knew the front had moved. And guess what? It moved northward during M2, which is pretty interesting because it suggests the Agulhas leakage weakened significantly. Now, if you were expecting less salt to enter the Atlantic due to weaker leakage, you'd think the AMOC would struggle. But that's not what happened. Instead, the Atlantic circulation intensified in lower latitudes, and the thermocline, the boundary between warm surface water and colder depths, became shallower across much of the Atlantic. This led the researchers to a broader ocean reorganization. They compared data from various sites and found that two temperature indicators started diverging around 3.4 million years ago, indicating colder subsurface waters and a thermocline moving closer to the surface. This wasn't just a local anomaly, it was a basin-wide phenomenon. The simulation supported this geological evidence, showing a stronger AMOC at greater depths and lower latitudes during M2, but weaker near the surface and north of 58 degrees north. So, what does this mean for our understanding of the Atlantic circulation? Well, it turns out that the salt supply from Indian Ocean isn't the only factor controlling the AMOC. Local processes in the North Atlantic, like high-latitude precipitation, sea ice, and the location of deep water formation, also play a significant role. The late Pliocene geography was different from today, which adds another layer of complexity. The study's implications are pretty cool. It challenges us to rethink how different parts of global ocean circulation are connected. Agulhas leakage still matters, but its impact on the overturning circulation depends on the climate and the geography of ocean gateways. So, when studying the AMOC, we might need to consider both southern salt supply and local North Atlantic conditions. Lastly, this research highlights the importance of geological records from multiple ocean basins. What might look like a local pattern in one core could be part of a much larger oceanic reorganization. It's a reminder that our understanding of Earth's climate system is constantly evolving. So there you have it. This study shows that our understanding of the Atlantic circulation is more nuanced than we thought. It's a fascinating reminder that nature often surprises us with its complexity. Thanks for watching, and don't forget to like and subscribe for more insightful content.